First, let's try to visualize analog signals which reach Arduino input. For this purpose, special devices called oscilloscopes are used, but we are not going to connect our circuit to it. Instead, we will just imitate the way its program works. To accomplish this, we are going to make use of an outstanding tool called processing, which you'll be studying in detail next week. For now, you can download it following the link in the additional materials section, as well as download the program which I wrote to visualize analog signals. Start processing, open my program, and take a look at the line where the port is mentioned to which the controller is connected. You need to do it in a way so that its number corresponds with the actual port number that you can see in your system. Also, have a good look at this number. This is the connection speed. It should correspond with the speed mentioned in the analog read serial sketch, which you uploaded at the beginning of the experiment. Don't worry, we are going to speak about the connection speed in detail in the next fragment. For now, you should just pay attention to it when the program starts. After that, you can start the visualizer by pressing the Run button. We can see a window like this, which is empty at the moment because the potentiometer is set to 0. Now I am going to rotate it, and let's look at this line, which corresponds to the change of the voltage at the analog input. Since the potentiometer covers the whole range, we have witnessed changes from 0 to 1023. Apart from that, I have activated the display of the minimum and maximum observed values. This might come in handy when you study the voltage range communicated by various analog sensors. From this picture, you might have already understood that the input voltage changes unstoppably, meaning that at some point, it can take the value of, let's say, 2,8327 V. This value can be brought to further precision, but for some reason, we only saw numbers from 0 to 1023 on the screen. The thing is that when the signal reaches the controller, it undergoes certain changes. It passes through an analog to digital converter, aka ADC. If I try to explain the way ADC works in simple terms, it will be as follows. A special device known as a comparator can compare current voltage with some base voltage and communicate whether it has got 0 or 1 as a result of this comparison, and whether the current voltage is higher or lower than the base voltage. In case with a 10-bit ADC, this happens 10 times, and we get a combination of 10 ones and zeros, which, after being converted to a decimal number, displays the value from 0 to 1023. As a result, the range of 0 to 5V which we can communicate to Arduino input can be divided into 1024 units. In other words, the difference in units means that the voltage difference is approximately 0,005 V. In fact, it is a bit lower. Thus, we have a certain number at this input. But how do we work with it in a program? How does it appear there? Let's have a look. Let me bring you back to the example with which our experiment began, the one from the sketch template called analog read serial. You might have already realized that the function analog read is responsible for reading off the analog signal. This is another Arduino integrated function, which is designated to read off analog signals. It receives only one thing as a parameter, which is pin number. Let me remind you that you can refer to analog inputs by using their board indications A0, A, etc. All these notations are already built in the Arduino library. Please take note of the fact that the analog read function can be called to the right of the assignment operator, while to its left appears the name of the variable, which is set here, the integer variable sensor value. Last week, we already learned how to create int type variables. However, here I would like to draw your attention to the fact that when we want to read off values from a sensor, we have to use these values somewhere. In our case, we are going to save the value into a variable. You can also communicate it as a parameter to another function. or use it in your calculations. Many times I have noticed how beginner Arduino amateurs are simply trying to call the analog read A0 instruction when they want to read off data from a sensor. In reality, the controller possibly reads something, but the value that it gets cannot be found anywhere. This is why when you read off values from sensors, do try to understand where they go. The next thing that we will have to figure out is how exactly the data is communicated to the computer screen and how we can read it from there.